Welcome, everyone. This is Steve Hill, CEO of New Hydrogen, today with another podcast with a very interesting guest, in my opinion, and I think you'll agree with me once we're done. I'm pleased to be speaking today with Dr. David Blekhman, who's a professor at Cal State Los Angeles, who serves as the technical director for the Hydrogen Research and Fueling Facility, and has been recognized as a Fulbright Distinguished Chair and Outstanding Professor. Be sure to follow his regular commentary also on Forbes.com. And with expertise spanning hydrogen production methods to real-world systems like fuel cell vehicles, Dr. Blekhman offers valuable perspective on all things hydrogen. I'm super excited to have you here, Dr. Blekhman. It's a pleasure to have you and welcome.
Oh, thank you. And pleasure to meet you and all your audience.
Glad to have you. One of the things that intrigued me right off the bat is this hydrogen houses. At some point in the past, you went to Sweden to tour this hydrogen house. So what is a hydrogen house? And then please share what your thoughts were.
Well, I was in Sweden in 2019-20 as a Fulbrighter at Chalmers University. And so I started hearing about this hydrogen house that I should visit in Gothenburg, and that's where university was. And with a few colleagues, I went there, and I was so impressed with this solution to energy independence for a residential application. So the house has a solar system on it, and then battery system involved for storing hydrogen, electrolyzer, a fuel cell, and storage. And then in Sweden, they're also using geothermal, and the way Hans Olof Nilsson, the engineer and designer and the owner of this beautiful house, he also uses geothermal application for compression. So there is a temperature difference that is at play. So when I saw this house, I was so impressed. I said, I want to, not only as a solution, and we can talk more about it, but I also wanted to have as a record for my students to bring it as a project, because I also teach fuel cell course and look at applications there. And I wanted to bring that whole theme into my program. And so we even created a documentary. So, and this documentary exists on YouTube, Hydrogen House. It's 15 minutes, very quick walk through the house and back and forth on technical issues. And I really like reading comments. Some people like hydrogen, some people don't. The unique solution we have in Sweden is that the storage of hydrogen is for seasonal storage. And so all of the hydrogen is created during summer, stored in storage. So you have to have a sufficient storage for residential, but it's quite possible, not that too much. Mm-hmm. And then the hydrogen is used in a fuel cell in winter or other days when there's not enough sun. Mm-hmm. Yeah. And they produce electricity, and they produce heat. Fuel cell produces heat. So the heat is used for heating up house, and then electricity is used for any other applications that they might need.
It's an incredible application, and actually I recommend that video. I did see it. You sent me a link to it, and I really enjoyed watching the walkthrough. If you want to see what this hydrogen house looks like, I highly recommend that you visit this video. That's the hydrogen house on YouTube. And Dr. Blekhman will walk you through kind of the mechanicals and some of the strengths and weaknesses of the whole structure, but it's quite fascinating. So you said you brought some of those ideas back home. Tell me what you mean by that.
Well, I brought it for my class.
Okay.
For my students to work on this project and ideas. And the way we use it in class, I tell them, here's an example, and here's some information you can read. And it's at the end of the class. So it's a class project. And so they're already fairly well exposed to all of the electrolysis and fuel cell operation. And also they understand a little bit of a solar power. So then what would be analogous application in the United States? So in California, it's one thing, but I had conversations with people from Fairbanks, Alaska, and I said, well, a fair application for this concept of seasonal hydrogen storage isn't in Alaska. And so they are redesigning the system in order to accommodate houses in northern climates, not only in Sweden, but in Alaska. And so they're looking a little bit more of solar profiles and how they need to resize the system in order to fit with new equipment, right? So the house was built 2015, 2016. We already know that we are going through this change in technology in adopting hydrogen much faster than it was even 6, 7, 8 years ago. So there are new products on the market, new options, solar improving as well. So they're it's kind of to give them that exposure into market, to look at the replacement equipment, so and redesign the house with these new concepts. And what is important, what they did in Sweden, and as a solution, I really enjoy that the electrolyzer is not sized to the solar system. The electrolyzer is sized to the storage, to the battery storage, and the battery storage is sized to be a little bit more than your daily production of solar. And so then you don't have to supersize your electrolyzer. Electrolyzer just runs all day long, 24 hours during summer. So that's kind of the concept built. So I like that, because when we are now looking at system designs and microgrid designs with the massive renewable energy production and using electrolyzers to do load following, maybe it's better done with battery storage, and then your electrolyzer could work continuously. So there are various approaches and ideas that can be taken, but I really like that hybrid design that uses electrolyzer and the batteries, and then in the winter it's a fuel cell that runs constantly and recharges the batteries, and then you can have your loads on and off. You know, it doesn't have to be like following the load, the fuel cell. It's just the battery that provides you dynamics.
So we're looking at, I mean, this is a super creative hybrid sort of option to power and heat a home in northern climates. But I know also a little closer to home, SoCal Gas has a hydrogen project home, or at least did some kind of a project home. What are the differences between those? Have you seen that one, and what are your thoughts there?
Yeah, I saw it several times, and I visited and learned it from SoCal Gas. And so they're solving multiple problems with this interesting project. Fascinating, you know, trailblazing is difficult. You need to convince people that it's important. And so I really praise SoCal Gas, and they're doing it just like a half hour from Cal State LA. So it's so easy to visit. And so this is and they're so busy. It's so hard to schedule just even to go to see that. But I would encourage all of the professionals take opportunity and connect with SoCal Gas on this house. They are solving a different problem. They are looking at as a community, even though it's a one house, and they call it innovation space. So they have a system that could actually service several houses. So if you look at it, you say, well, it's not properly built for one house, but it's properly built for a community, right? Mm-hmm. And so they just cannot, in their backyard of their innovation space, they cannot just build so many houses. Yeah. But conceptually, it's very good. They have hydrogen blending. And it's something that SoCal Gas is very interested in, combining hydrogen with natural gas and making natural gas a little bit greener that way. And so having this allows them to build their engineers, all of the company culture around green, even though it might not be perfect in every aspect, but it's their learning tool, their hands-on lab, you know, their living lab.
Well, it sounds fascinating, and it's not far from where you and I are. So if you ever want to go down there, those who are watching, put some comments in there. If you want to see Dr. Blekhman and I book a trip down to this hydrogen neighborhood concept in Southern California, let us know, and we'll go check it out. Dr. Blekhman, I'm thinking, though, of, you know, this is an interesting application in housing for hydrogen. People don't think of that often. And what a lot of times we're thinking about, just because of the prevalence of Toyota Prius and some others, is sort of hydrogen in transportation. And one of the really cool, kind of different new things that's out there is this concept of Formula One and something called Extreme H. Extreme E was the electric version. Extreme H was just hydrogen. So you're throwing racing cars and like off-road high performance and hydrogen all in a blender, and you're creating this new sport. And I'm just curious. I mean, the Hydrogen F1 and Extreme H just announced that they're working together on a joint hydrogen technical working group. To me, that bodes well for the future, but I'm really interested in what your thoughts were. Is what does this do for hydrogen and hydrogen development? What are your thoughts in general?
Well, it's a multidimensional kind of undertaking, and let me unfold it for you. It's like stepping into multiverse of things. When you talk about sports, automotive sports, first of all, it's extreme technologies, right? So you're going into creating solutions that don't exist, and they require extreme environment to operate. And so then these solutions then find their way into everyday cars or in everyday fueling solutions. Like innovation happens and then it trickles to consumers. So that's one aspect which is very important in terms of and so I'm expecting this big push for hydrogen, or better solutions coming out for hydrogen, new catalyst, new fuel cell, new power plant design or power flow or configurations, because you can, fuel cells are not fast. Maybe we can get fast the fuel cells and you don't need the batteries, but right now fuel cells and batteries have to work together, so it's actually a hybrid system. But if you think about batteries and battery extreme sports, cross country, whatever, then the batteries need to be recharged. Do you carry big weight with you, the batteries for full distance, or you recharge periodically? So all of these kind of things are challenges for batteries. And then if you look at the benefits of fuel cells, they're offering us a longer distance, lighter weight of the vehicle. And so maybe those solutions could be beneficial, and maybe faster refueling than recharging. Like you don't have to stop the whole race, but maybe you can have full race. It depends what they will come up with the rules, and it's always to the extreme, right? And the last point I want to bring up with this benefits, and well, actually there are more points, but is the sports are watched by so many people, right? So now you can share knowledge and ideas and talk about it with a huge audience of those motorsports, right? And get them excited about hydrogen. So this is a spectacular opportunity to educate masses about hydrogen. I also want to say that it's not only Formula One, but I have in Forbes a couple of articles about company Goisson, French. They created a racing track for Dakar races in 2021, so that was fantastic. And in another extreme automotive sports is supercars. Here in California, we have Hyperion creates a hydrogen supercar. So this is, all of those guys, even though we understand those vehicles are extremely expensive, but it's what drives innovation. And so that's what I'm looking for, the outcomes, and then trickling it back to us.
I just saw the Hyperion supercar at the Catalyst H2 conference in Huntington Beach just recently, and it is impressive. That is an impressive piece. It looks like a Bugatti. It's a very impressive piece of machinery and engineering. If you get a chance, maybe we'll put up a little video here so people can see that one as well. It's very impressive. But I love your point here is we're coming at this from different angles, right? We've got government for support for hydrogen. For most people, that's a little boring. We've got innovations happening on the electrolyzer technology that's very specialized. A few people know about that. Most of the general public probably doesn't know too much about that. But when you start getting into things like racing, aviation, housing, now you're starting to get into applications that people touch on a daily basis that really it's interesting. And that spark of interest is what we need to start moving this conversation forward. We've already got great momentum going, and this will just continue to build on the high-profile nature, these high-profile programs to bring hydrogen more to the forefront. And the more that gets invested, to your point, the greater the innovation and technology will develop. It trickles down, just like NASA and space technology, all that cool stuff that it took to get people to the moon resulted in amazing innovations here on Earth way back in the 60s. And now we're having the same thing happen again. It's a hydrogen revolution. And speaking of that, Dr. Blekhman, there's another thing. Speaking of your publications in Forbes, you had recently talked about this Hyundai hydrogen trucking program that's in Oakland. And I was shocked to see also Switzerland. Not that Switzerland's not awesome, but it's a small country. What is this? Tell us a little bit about your article, and what is this thing that Hyundai is doing, and why in Switzerland and Oakland?
Well, Oakland is because of the port. So this is a good project where we are bringing 30 Hyundai trucks. What we heard recently, the infrastructure was enabled. And so the project can commence with the fueling of trucks and deploying them as, port serving trucks. Where in Switzerland, it's already a several-year-old program, maybe a 3 years old program, and it's a unique solutions. First time I heard about Hyundai working in Switzerland was 2019. That's when the project was announced. I said, amazing.
Yeah.
And even more so, there are so many cool solutions there. First of all, Switzerland experiences very high taxes for freight. And therefore, if you're a sustainable vehicle, electric or hydrogen, then it's free. You don't pay the tax, road tax. And so at first they tried to use electric trucks, and it was not a good solution for goods transport in Switzerland because of the mountains. So the trucks were not meeting their needs. And so hydrogen provided that extra long distance and ability to perform over mountains, and that's much better solution. Also, Hyundai has a unique business proposition where you don't buy trucks, you pay per mile. So the use of trucks is important, and they get paid by mile. The owners of the trucks get paid by mile by the companies that use the trucks. So that's kind of and they provide full service. So there is no challenge for the trucking companies to rent those trucks because they are not responsible for service. They just pay per mile.
And I'm understanding that they've logged already like 4.5 million miles from your article, something like that.
Yeah, that's it's impressive of mountainous driving, and it's also 47 trucks in service at the time when we were interviewing in May. And what I like about the hydrogen solution is hydroelectric. And hydroelectric is the best because then you're producing hydrogen with electrolyzer. It continuous load, so you don't have to think about intermittency. And then several hydrogen stations are enabled in Switzerland. So this project has a fantastic effect in Switzerland and proving that there are really good business cases for hydrogen and clean transportation.
I think we can expect to see more and more of this crop up worldwide as there's a need, right? Switzerland has a very particular need that drives this innovation. It's taxes on the vehicles. It's a challenging environment for trucking, and it's leading to this innovation. And that means innovation not only in the trucking, but also in the financing and the other realms that play together. And this is an excellent test case that I hadn't heard about until I read your article about this. So thank you for sharing that. And follow Dr. Blekhman on Forbes. You're going to see some fascinating articles that he puts out there. You can tell he's an interesting guy just by talking to him. He's got such a breadth of experience. But, one of the challenges here, and you alluded to this earlier, is mixing hydrogen. There's blending hydrogen. We're thinking about now, if we can manufacture cheap hydrogen, which is what we at New Hydrogen are working towards, we'd like to create the world's cheapest green hydrogen. But even if we have really, really cheap hydrogen, that's awesome, but it's got to get places, right? We have to get this hydrogen to the fuel refueling stations. We have to figure out how to transport it. And that's not anything new, but on a much larger scale than we've ever done before. There's something that many people have read about, and it's called embrittlement. And you can explain this much better than I can, Dr. Blekham. But in essence, this is if we decide we're going to use the natural gas pipelines that are already in place, and we kind of do this blend, hydrogen is a different element, and it tends to degrade the structural integrity of these lines. And so that could be a problem. And so I'm curious, from your view, how are we getting around that? What kind of progress is being made in that realm?
Well, of course, that's the realm of material scientists. So we have this special group of engineers who are called material scientists, and they study this quite extensively. And speaking of Auckland, there was a hydrogen station there that in the pressure relief valves, they used incorrect metal that got embrittled, and one day it basically opened up and the hydrogen leaked out of the storage. Nothing happened, because usually hydrogen just escapes into the air. It's like 15 times lighter, escapes really quickly. But nevertheless, Pixar Studios was evacuated. So if you have wrong metal used, you might get in trouble. What we find out that even a small percentage of hydrogen can be creating embrittlement. And the way it works, if you imagine a lattice of metal, hydrogen molecules are so small, they kind of get in between and kind of weaken some of the connections there in the lattice of the metal. And so one of those, kind of for certain energies, and then metal will flake off. And then there is a metal hydride storage that is based on that the hydrogen can be stored inside of the metal structure, but metal becomes a powder at this point. However, the way we are looking at current pipelines, the pressures are relatively low. So for hydrogen to get deep into metal and weaken it significantly, it really requires slightly higher pressures than pipeline. So small blends, and I think currently it's accepted about 20% blends. Energy-wise, it's not affecting gas too much. You can still have the same appliances running on the blend. 20% of hydrogen by volume is acceptable. But we also could, besides blending of hydrogen to pipelines, we can have dedicated pipelines. We can have liquid hydrogen conversion. It costs us 30% of energies, therefore it's not very preferred. But also there is another alternative, is chemical conversion to liquid fuels. So we can have liquid methanol if we're capturing CO2, or we can do ammonia if we're capturing nitrogen from air. So there are different solutions, and that universal behavior and plurality and ways we have multiple opportunities to transport hydrogen across distance if necessary. Of course, once you make it, it's better to keep it just hydrogen and use it. But same with oil, right? It goes across oceans in big tankers. So we have to transport our fuels, and hydrogen is a fuel. And I really like the opportunities hydrogen creates in terms of maintaining renewable energy focus. And that hydrogen revolution is because of its ability to fulfill so many niches.
And all these issues are hard nuts to crack, and yet we continually see new innovations coming forward, and it makes the future so bright and hopeful to me. I'm just so amazed at all the innovation that's happening, and grateful for everyone who's working so hard, investing in this technology, and educating students about this technology. So we have another future wave of technologists, materials scientists, chemists, and everyone else needed to engineers in order to make this a reality for the future. So maybe in a parting shot, I'm curious, in your view, how cheap would hydrogen have to be able to make all of these things mainstream?
as cheap as the market allows, right? So, so you can't go around it. So what we need, so if you think about hydrogen right now and all that renewable energy, well, although like in some countries, renewable energy is almost 100% could be fulfilled. And there are some moments and minutes in California where we get all of our electricity from renewable. But converting to this clean and going through the clean revolution, the analogy I'm using is just, we are just at this a starting line, and we just, in slow motion raising our first leg, right? And so all of the solutions are needed, and workforce opportunities are also exciting. Like we had like a computer revolution recently, and now we're going to have a hydrogen revolution and renewable energy revolution. So all of these new professions, and as a professor, I really enjoy being able to train students in that cutting edge technologies. And even if you have a traditional engineers, civil engineers, and chemical, whatever, electrical, mechanical, just giving them a couple of more courses or a little bit more training in hydrogen technology would really prepare them for entering that market successfully and moving this forward along.
Dr. Blekhman, I don't think I have covered as much ground in a single podcast as we have today. We need to talk about scheduling a part 2, because I have so many questions that I would love to hear your feedback on. So if you'll commit to it, we'll see if we can figure out another time to connect again and talk about some of these fascinating developments that are happening worldwide. Thank you so much.
Well,
excellent.
Yeah. Yeah, thank you for bringing me in.
Yeah, thank you for sharing your perspectives on
in.
everything hydrogen today, from trucking to residential to infrastructure. We've covered the groundwork. And if anybody watching would like to learn more about Dr. Blekhman's work, you can check out the video on our website. This will be republished on our website at newhydrogen.com, and we welcome you there. Thank you, Dr. Blekhman. It's been a pleasure.
Thank you. Likewise.